In this example, we're going to explore what happens when we multiply the outside of a function by a constant. So I've opened a Desmos window with the function p of x graphed. This same application is linked from the online lecture notes, so you're encouraged to open it and play with it yourself. So in addition to p of x, what I've also graphed is a function v of x, where v of x is essentially the exact same function p of x, but with a constant multiplied on the outside of the function. And just real quick, I want to mention that I refer to this as the outside of the function because when we're working with this function p of x, we'd start by putting an x value inside the function, an input, find the output associated with that x value, that's what p of x would represent, and then we multiply by this number a. So a is on the outside affecting the outputs of the function p of x. Now I've started by letting this number a equal 1. That's what the slider here allows us to do. So I can vary the value of a just by sliding this number, this little slider. Okay, so what we'll do is let a get bigger and bigger and bigger. That's how we'll start. So the first thing I'll do is let this slider go towards the right and get bigger and bigger and bigger. And let's see what happens to the graph of v of x. And notice that the outputs get bigger and bigger and bigger, which is exactly what we would expect when we multiply the outputs of p of x by a number bigger than 1. So when this slider represents the number 3, our outputs that used to be here when we put in like negative 1.2 or something, we got the output 2. Now we're getting the output 6. We're getting an output 3 times bigger. And when we step back and look at the graph, we see that the graph appears stretched in the vertical direction. So when we multiply the outside of a function by a number bigger than 1, we stretch the graph vertically. Now let's go back when a is 1, and now our two graphs line up perfectly because we aren't stretching or compressing the graph at all. We're just multiplying it by the number 1, which doesn't change it at all. So now let's see what happens when we let the number a get smaller than 1. Now when the number a gets smaller than 1, our graph gets compressed in the vertical direction because we're like dampening those outputs by factors less than 1. So for example, if a is 1/2, we're multiplying the outputs of the function p of x by the number 1/2, so we're making those outputs half as big. So when we step back and observe the graph, we see that the graph has been compressed by a factor of whatever that number a is. So in conclusion, we can recognize that when we multiply a function on the outside by a number bigger than 1, we stretch it vertically by that factor. And when we multiply by a number less than 1, we compress it vertically by that factor.